So our today's first topic is coupling of chemical reaction. So the question arises is what is coupling of reaction? Joining of two chemical species together with help of metal catalyst. Types of coupling we can classify like there can be a direct coupling reaction, there can be indirect coupling reaction, there can be Suzuki coupling reaction, there can be Negishi coupling reaction. So there are many more. So talking about the direct coupling reaction, in that there will be no intermediate, like there will be a reactant and there will be a product formation direct, there will be no intermediate in between. Talking about indirect coupling reaction, there will be an intermediate, there will be first reactant, then the intermediate, and that intermediate will go in further reaction, and that there will be a product formation. So reactant, intermediate, then product. So it is known as indirect coupling reaction. So in indirect coupling reaction, there is furthermore cross coupling reaction, homo coupling reaction, nucleic philic reaction, electrophilic reaction, many more, catalyzed reaction, non-catalyzed reaction, and so on. So here the R is organic group and M is central metal atom. So now we'll see cross coupling reaction. So in cross-coupling reaction, we take different kind of reactant, and in homo-coupling reaction, like the name is saying itself, like in homo means same, and coupling means join the two reactants join together. So homo-coupling reaction, in that we will take two same type of reactant. Here's giving about homocoupling reaction in four types. Reaction whenever we need a higher amount of alkane. So what we take two alkyl halide and sodium, two molecule of sodium, and in presence of dry ether. Remember that whenever we use Wurtz reaction, the dry ether is mandatory. Without that, well, there will be no Wurtz reaction. So dry ether is mandatory for that. So there will be alkyl halide, then sodium. Then in presence of dry ether, we'll get higher alkane and 2 sodium halide. So this is Wood's reaction. It is pinnacle coupling reaction. You can see with the animation. It is Glaser coupling reaction. This is Ullmann coupling reaction. So moving towards our next topic, steady state of linear system. So in the context of biophysics, the steady state of linear system refers to a condition where system variable such as concentration of substances, electrical potential, or other measurable quantities, they remain constant over time despite ongoing processes or inputs. The concept is particularly important when studying biological systems that can be modeled using linear differences equation. So in key concept, we can see linear system and steady state, and there is also dynamic equilibrium and all other things. First, we'll see linear system and steady. You can see the equation of steady state, that is dx by dt is equals to 0, where x represents the state of variables of system. Talking about the dynamic equilibrium, in biological systems, steady state often implies a dynamic equilibrium in process are ongoing. Example, metabolism, transport are signal, but they do not lead any changes in concentration or state. In dynamic equilibrium, we can say that the rate of forward reaction is equal to rate of backward reaction, or the rate of backward reaction is equal to rate of forward reaction. In that, what is happening, that there is a state of dynamic equilibrium, that with the naked eye we can't see that something is happening. It seems like it is static. For example, we can understand this with the example of this. So in this we can see the first type, it is describing the rate of backward reaction, and the second one is describing the rate of forward reaction. In between we can see that it is in the water inside the bucket is in dynamic state. But with naked eyes we can't see the water is flowing. It seems like the water is still, but it is moving, but we can't see it with naked eyes. So these are some factors which can affect the dynamic equilibrium. So these are the application: metabolic pathways, cellular signaling, and neurophysiology. So in conclusion, understanding the steady state in linear system with biophysics.